Let's start. In the middle of Utah, in western United States, deep in a forest, lies the biggest giant known to us. It's the oldest one thus far. It is still alive, and it clocks in at an impressive, a staggering 80,000 years old. In Utah, we find Pando. That's that giant right there. Genetic testing has helped confirm that each tree in the forest is the same organism reproduced over and over again with only slight genetic variations. Scientists believe that every tree in the Pando colony shares the same root system. So imagine so many trees in this giant root system. The result is one of the largest, as we've said, oldest living systems on Earth, and a remarkably resilient forest as well. Now, Pando's deep connected roots have allowed it to survive millennia of fires, droughts, climate shifts, changes in temperature, and diseases as well. In the heart of Utah, we see the most flexible and reliable system known to us. Now, on first sight, Pando feels like a miracle, and close. It almost is, because Pando is a system that understands the elements, the interconnections, and the purpose that it fulfills. This makes Pando a system that is as aware of itself as the purpose that it fulfills. And it's precisely organisms such as Pando that gave us the kickstart into systems thinking. Now, systems thinking started with an impulse and a thought. Could we learn from biology? Could we learn from Gestalt psychology as well to help us understand complex organizational and social problems? Absolutely, we can. Now, before we dig deeper, we still need to understand the definition and anatomy of a system. A system is simple. It's a set of interconnected elements coherently organized in a way that it achieves something, anything. For Pando, for example, it might be preservation of life, longevity of life as well. Lucky for us, we don't have to look far to look at successful systems. A system is anything, a set of things, people, cells, molecules, whatever, interconnected. That's the key. Interconnected in a way that they produce their own pattern of behavior over time. And that's what we're going to be focusing on, behavior over time. Now, systems, once we learn what to observe, are easy to spot out. Every person we encounter, every organization, every animal, garden, tree, forest is a complex system. We are so wired for systems that we just blindly follow systems, like the London Underground system or the New York City subway system. These are systems that have a deep understanding of their past, which helps inform their present, and then it also gives them an ability to prepare for the future. These systems have bent many times, and this is actually not real. It's an outlook of what the London Underground system could look like in the year 2040. But if there's anyone from the UK, this system is not completely unknown to us or to someone that commutes regularly in London. It shares the same purpose. It shares the same elements, and its interconnections are very, very clear. For the New York City subway system, if we peer inside of its system, its manual, we see flexible and resilient elements and interconnections. Like this, for example. We could put any words there. We could put any number there. It's a system that can bend. We also self-impose systems. This is Picasso during his blue period. He painted essentially monochromatic paintings in shades of blue or blue-green with occasionally warmed by other colors, like orange, for example. The system that he created produced its own pattern of behavior. In a time where he was in the midst of emotional turmoil and also financial hardship, he wanted to he wanted to find creativity in those times. So he resorted to creating a system, a self-imposed system. And his blue period is one of his most renowned periods of time during his work. We are also a product of systems, like schools. A school is a system, so is a city, a factory, a corporation, a national economy. The place that we are right now is a system. An animal is a system, as we've talked. A tree is a system. And a forest is a larger system that encompasses subsystems of animals, trees, and anything living inside of it. Let's continue using Pando as our example. What makes Pando a resilient and flexible system is that, as we've said, it's aware of itself, and it's aware of its structure, and as a result, it can modify its behavior. Take forest fires, for example. During intense fire, this organism survives underground, with its root system sending up new stems in the aftermath of each wildfire. By understanding the structure of its system, Pando is able to withstand fires by changing its behavior and, of course, modifying the entire outlook of its system. Its elements change completely. As we mentioned, if we carefully observe, we can also understand what makes a system produce poor results. An example of a poor result, in my opinion, can be found in the North American jury system. So the structure of placing 12 individuals, which we will call elements for now, 12 elements together to play a key role on the output of the judicial system, is not taking into account the behavior of the system. We do very little to understand the elements that make up this organism, the jury system. What are their stories? What is the context? What are their psychographics, their attitudes, beliefs, and behaviors? As such, we run the risk of being left with juries that are biased towards a specific point of view, culture, or even economic background. This is why thinking about systems outside of the design prefix, design systems, just systems, is imperative, especially in our field. Now, I know that our interest levels leans towards design systems. However, I would like us to think past the outputs of a design system and dig into the why a little bit more. The purpose of a system is to solve problems and create desirable futures with minimal side effects, if you can avoid them. Before we can peer into the future, let's understand the anatomy. We know a few words already, actually. Elements, easy. Any system is comprised of a finite amount of elements. These elements contain interconnections, pathways through which each element can associate itself to one another. In the case of juries, for example, this is exactly what is missing. We don't have any interconnections. Lastly, elements and interconnections define a system's purpose. And this is the third and most important component in the system. So let's take a look at elements. Easiest parts to notice, because many of them are visible, tangible things. The elements that make up a tree, for example, are roots, branches, leaves, and we can even look closely into the leaves and find even more elements there. Vessels carrying fluid up and down, cells, molecules, as we've discussed. We can apply the same logic to a university. The system is made up of buildings, students, professors, administrators, computers, books. These are all elements. What's interesting about a school and what a school can teach us about systems is that elements don't have to be physical things. They can also be intangible things. In a university, school pride is a very important element. It can define almost a system. It can help, for sure, define a system. In a design system, providing clarity, that can be, it's an intangible, of course, and it can be an element equally as important as that button element that you've just finished designing. Elements are also the parts of the system that suffer the biggest change. For example, as the days get shorter, like right now, a deciduous tree like this puts forth chemical messages that cause the nutrients in the leaves to migrate out of the leaves and into the trunks of each tree, allowing, of course, this tree to survive the winter. And as a result, that causes the leaves to weaken, to die, to weaken and fall. And we get these beautiful colors as a result, as we transition into winter. This shows us a key point, something incredibly important. Elements should remove themselves when they have helped a system achieve its purpose. If we were to place this logic in a design system, we can begin to ask ourselves and each other, when was the last time that we pruned our design system? Or when was the last time we audited that design kit? That navigation element or that button that was key, a key element of the system, might be unnecessary, unneeded right now. It might be in the best interest of the system to prune that element away. Just like a tree, an element that has fulfilled its need should be recycled. If elements are hard to see, functions and purposes are even harder. A system's function or purpose is not spoken, written, or expressed explicitly, except, of course, through the operation of it. This is where behavior comes in. The best way to deduce a system's purpose is to watch it for a while to see how the system behaves. So example, if I drink coffee, I'm a system, we are all each other's systems. If this system drinks coffee twice a day, 8 a.m. and 1 p.m., my purpose has nothing to do with drinking coffee. My purpose has everything to do with staying alert, for example. If a thermostat allows you to turn the heat up and down in a building, the purpose of a thermostat has little to do with customizing temperature, but with keeping a building's temperature at a steady interval. Something really special to systems, and I think this is where we have our biggest capacity for change and positive change, is to consider that systems can be nested within systems. We talked about a little bit about like a subsystem, a forest, a tree inside of a forest, for example. So there can be a purpose within a purpose. Example, I think we can all agree that the purpose of a hospital is to care and preserve life. Within the hospital, the purpose of a nurse might be to provide the best care available. The purpose of a researcher might be to find groundbreaking evidence and data. The purpose of an administrator might be to balance the hospital's budget. Any of these sub-purposes come in conflict with the overall purpose of caring and preserving life, and the system goes in disarray. The nurse could stop showing up at work. The researcher might ignore relevant data, and the administrator might balance the hospital's budget by firing nurses. Any of these come in conflict, and we end up with a discordant design system. As you set out to either build or maintain your design system, ask yourself, am I creating a subsystem within a system? And if so, are all my purposes in contact and in harmony? Let's go for an example, very simple one. A basic example it could be font size and spacing. So let's pretend that I need to build a design system that is clearly legible and usable from a distance. That is my overall system purpose. It doesn't stop there, obviously, because my font subsystem will ensure that I'm using large fonts and clear content hierarchy. It doesn't stop there. My spacing subsystem needs to allow for significant vertical height. Otherwise, the lines will be very hard to discern at a distance. It doesn't matter if I'm using 60-point font. If vertical height is still very, very narrow, it makes it hard to read. It doesn't matter. It's important to note that it doesn't matter which purpose we are taking a look at any point in time. What matters is that all purposes are coherently organized, that all North Stars are pointing the right way. Understanding the anatomy of a system is critical for us to ensure that we are building systems that align with our purpose, as we've mentioned. Now, and as we go on to build, maintain, evolve the systems that we've built, design or not, we will naturally be faced with options, challenges to change these systems. I think change is a core competency of any system, and it's something that we absolutely must do on a regular basis. So let's take a look at how much we could potentially impact by changing parts of a system. You can understand the relative importance of a system's elements, interconnections, and purpose by imagining them changed one by one. Elements are first. So elements have least effect on a system. These are the cells in your body. Your body replaces most of them every 3 weeks, but it goes on being your body. As long as the interconnections and purposes of your body remain intact, Your body goes on being itself, and any system goes on being itself, changing slowly, if at all. Interconnections are looked differently because they do greatly alter a system. If patients took care of nurses, or if research was won by debate instead of by evidence, a hospital's function would change so much that it would need a different name. It wouldn't be a hospital anymore, obviously. And functions is all about purpose. And these obviously change dramatically. What if the purpose of a tree was to be the smallest tree possible? Our forests would look nothing like they do today. What if darkness caused flowers to blossom? Our nights would look much different. We would go out on adventures at night to watch these beautiful things blossom. It's unsystematic to ask whether purpose, interconnection, or elements are more important than the other. All have their own unique role in a system. It's what makes it a system after all. If you are in a position where you're faced with changing the interconnection or the function of your system, reevaluate if your purpose remains the same. It usually doesn't. For example, if your design system is meant for the web, but the function of it changes to serve mobile devices as well, the purpose is now different. The purpose of your system has now changed, and there is nothing wrong with updating a purpose. The trick is remembering to look at your purpose to ensure that you're still aligned. Most of us get caught in the ruffle of the leaves, the elements. And I think that is the tension that I feel, at least, with design systems. As a person working on creating, maintaining, and evolving a design system, I feel like we run the risk of getting too caught up in the elements of design system, the buttons, the forms, the text fields. And as such, we miss the forest from the trees. As designers tasked with building systems, we should be reframing our mental model of what constitutes a system. A system is not a set of objects. A system is a set of intended behaviors. We should be focused on promoting behaviors we wish to see in a system and not square our focus on elements alone. Now, behaviors are very complex, and they also speak to the relationship between us and the world around us. Many of the things that we design today are nested behaviors. They're complex things. As such, we need systems to help us make sense of them. We need to be building our very own Pando. This is why it's imperative for us to observe. We run a huge risk if we don't look at the people using our system. Observe the behavior of it. Watch how it breaks in order to reinvent it. Purposes are deduced not from rhetoric or from stated goals, but from behavior. Even if we watch systems intently at work, here's the risk of systems and why we need to be even more aware of their purpose and behavior. Because of feedback delays inherently built with any system, by the time that a problem becomes apparent, it could be unnecessarily difficult to solve. Hunger, poverty, drug addiction, environmental degradation, these wicked problems have persisted because once these systems were observed and a problem became apparent, the problems became much too challenging to solve. For us, of course, we have much more leniency. We're not, maybe some of you are, solving these problems head on. This is precisely, however, why we need to build observation as that core competency of any system designer. It's important to note that observation can be a double-edged sword. Take Paul Anderson. He says, "I've yet to see any problem, however complicated, which when looked at in the right way, did not become still more complicated." And I think a lot of us can agree to that. To that I say, maybe any designer says, so what? So what if the problem becomes more complicated? By observing a design system at play, we might be opening up Pandora's box. A wealth of added complexity might be inadvertently surfaced. The latter might be true. However, observation gives us all the clues and hidden gems that we need to make the problem simpler, not more complex. Observation can open up a wealth of added complexity, but that does not mean that we also need to make the system more complex. The complete opposite. We have the opportunity to make it more simple. Systems allow you to find agility of decision-making in the unfamiliar and rapidly changing environment. And I think a lot of us make that mistake, that believing that a complex system is a complete system. I think that is absolutely false. Effective systems around us prove that simplicity is a key to longevity. We think that complexity equals resiliency. I think we are wrong. This is not true in biology, and it isn't true in the systems that we build. The answer to complexity isn't simplicity. It is transparency. Design systems do just that. Any system does that. They might not necessarily offer that simple view of the world, but they definitely offer a transparent one, a modular one. An effective system is one that enables the user to see all variations of that system. It empowers them. It encourages them. It allows them to follow into the future with knowledge that they'll be able to get there. We need to design systems that are opinionated enough to withstand wildfires, but flexible enough to weather the changes in temperature. And this is where we also get a chance to deduce purpose out of behavior. And again, I really want to focus on that observation aspect of systems. I think that we create systems and we treat them as museum pieces. Once that system is created, we put it there. After all, it's the only way that we can look into the future, by understanding our system and making sure that the system is in tip-top shape. Absolutely, but what about behavior? What about the people that are using our systems, design or not? And what about changing? What about understanding that if a new behavior is surfaced, understanding that the system can also be empowered to change? I think a messy system is a healthy system. I think that a confused system is a great system, because those two qualities will ensure that your system never breaks. Thinking in systems allows us to build for impact, influence, output, and quality. However, I think the work is on us to make these systems opinionated, flexible, and future-proof. Observe the system in order to evolve it and understand the patterns of behavior. I'll close out with this great quote. It's one of my favorite quotes. It's by an urban designer, Ben Hamilton Bailey. He says, "If we observed first and designed second, we wouldn't need half of the things that we build." Isn't that true? Think to the systems that you've built, inadvertently built. You might have designed something that wasn't needed. I know that I have in the past. I've designed something, spent so much effort, only to understand that through behavior and through seeing how these patterns of a function come up, the system that I built was completely unnecessary, or at least it was too complex for it. A simpler method could have been achieved. Thank you so much, and I hope that this talk allows you to think about not just design systems, but the systems that we all use every single day. Thank you. Thanks.